All right, before diving into the world of LangChain and advanced AI concepts, I want to take a moment to address something important. I know that many of you watching may not be experts in Python. Some of you may even be coming from a different programming languages or even from non-coding technical backgrounds, and that's totally fine. I myself come from a C# background. In my day job, I am an architect who works primarily on Microsoft tech stack. So Python is not my first computer language, if that's a thing, but here I am teaching Python out there on the cloud and LangChain, just because I learned it out of my own passion on my own time. And I'm here to help you guys who's coming from a similar background like me, or who's not from data sciences or machine learning and want to learn LangChain and other AI concepts. I want to help you guys with this Python tutorials. So just to make sure everyone is on the same page, I'll be doing a quick tutorial on Python fundamentals. So that's what this video is going to be. You may be asking, why Python? Well, because Python is the backbone of LangChain and many other AI tools. So knowing the basics like how to work with arrays, loops, functions, and environment variables will help you avoid roadblocks later and get the most out of this series. All right. So think of it like building a foundation. If you have a solid base, you'll be able to tackle complex AI challenges confidently and productively as you continue through your LangChain journey. So stick with me. This won't take that long, and I promise it will make everything else in this course click more easily. Variables and data types. These are the most fundamental blocks of any programming language. So let's start with them. In Python, variables don't need to be explicitly declared, making it flexible but sometimes tricky if you're coming from a strongly typed language such as C# or Java. We'll explore how Python handles integers, floats, strings, and more, so you can manipulate data effectively in your code. Okay, I'm going to switch screens. See in front of you, we have a notebook called 03_Python fundamentals. Once we're done with this tutorial, I'm going to be uploading it. I'm going to be uploading it into my GitHub repo, so you can see it there. So in here, and also this Jupyter notebook will reside in a branch by the same name, similar name, 03 Python fundamentals. So you can either also switch to the branch anytime you want to go back and refer to this thing. So all right, with no more wasting time, I'm going to start declaring. I'm going to start putting in code, showing you how to declare variables in Python. So right here, so it's real simple. It's not strongly typed, so you don't have to specify the type of the variable before you can assign values to it. So here I assign an integer to the variable count, simply just like that. And similarly, if you want to deal with floats, again, you don't need to declare it. You just assign the value, just like that. Next, you want to assign values, string values. You just do the same thing, except that you surround your string value with double quotes. Okay. Now, if you want to deal with booleans, our all-time favorite, simple yet powerful, you just declare a variable and assign it either true or false, just like this. And now, if you have a suspicion if it's really assigning these variables and if this code is really compilable or I guess it's not a word, but if this code can be compiled, if it is syntactically correct, just let's do this, right? So let's do print, and in parentheses you put your variable name, just like that, and then you do shift enter, and then you will see that we didn't have any syntax errors, and it did print the value for isActive, which is true. Now you want to see if I change the isActive to false here and we do it again, you'll see it printed false. So it's working. Next, let's look at how do we define arrays or otherwise a list of values or a group of values in Python. So we call arrays as lists in Python. So, and the way you declare them is using this syntax. So you're going to surround your values with open, you're going to put your values between open and close square brackets. Okay, and the next thing I want to demonstrate is dictionaries. As you know, dictionaries are pretty popular. If you ever worked with any modern programming languages such as C# or Java, sometimes we call them hash maps. In JavaScript, mostly it's JSON objects, JavaScript object notation objects, and you know how useful they are. If you're not familiar with dictionaries, dictionaries hold key value pairs, and you get the value. You can access the value by using the key. So let me show you how to declare a dictionary first. So here, there you go. So in this case, here we declare a dictionary by name person, and it has two keys, name and age, and the name has a value of Sunil and the age has a value of 30. Arrays, they're called as lists in Python. They're super versatile in Python. You can store about just anything in them, and you can dynamically grow or shrink them as needed. I'll show you how to create, modify, and iterate through lists. And trust me, you'll be using a list a lot in AI workflows. Okay, let's switch back to my monitor. Let me show you in Python notebook how do we create lists. I mean, I already showed you how to create lists, but now we're gonna see how do we do things such as how do we access the elements and how do we modify elements and so on. So let me start with a new cell. So I can do that by pressing this, and again, let's create a list, something interesting list rather than 1, 2, 3, 4, 5. So I'm gonna make a fruits list. We're gonna declare a list of fruits just like that, and you can see this list has 3 fruits inside it. They are the apple, the banana, and I guess cherry. Okay, and how do we access an element in this list? We access the element by using the index of that element. So if you want to access apple, and if you count, apple is at index 0, banana is at index 1, cherry is at index 2. So to access apple, we simply do this. We will, if you see the name of the array or the list, sorry, in this case fruits, followed by open and close square brackets, inside which you put the index of the element you want to access. In this case 0. So if you print this, if you execute this using Shift F10, you'll see it printed out apple. And if you want to access, let's say, cherry, you do, as you can see, what is the index for cherry? That's right, it's 2. So you do that, you put it right here, just like that. And if you execute it, Shift F10, you'll see it gives you cherry. Now, what if you want to modify? What if you want to, instead of banana at index 1, you want to put blueberry? Let me show you how to do that. So do that by doing that. So again, you just assign it similar to a variable assignment, except that you are going to follow your variable name, which is list name, by open square bracket, and then the index name which you want to manipulate, and then close square bracket. So if you want to print, if you want to see if it did the job, you just print it using the print command, just like that. And let's see, as you can see, it changed it to blueberry. Previously it used to be banana. Now what if, so that's cool. Now if you want to know, this is fine, I want to start adding elements to this array, to this list. Sorry, coming from a C# background, I use the word arrays, but it's actually a list in Python, so you gotta pardon me. All right, and the way you add things to an array is using append method on the variable name which is for the list. So you use the append method, and here we go, and that's how you do it. So it's fruits.append, and then inside the append you put whatever data you want to. So in this case, let's say we want to add date. So let's see, what does fruits have. If we print the array fruits, I hope it prints it like that. You can see it now has 4 elements. Previously we had 3 elements: apple, blueberry, and cherry, because we manipulated the array, we modified the array in this with this command here. So it's apple, blueberry, and cherry before. Now we added date using the append method. Now we got apple, blueberry, cherry, and date. Okay, now how do we, of course, if you add an element, what if you want to remove an element? How do we do that? We do that by using the remove method, similar, and we use it the similar fashion as we use the append method. There you go. So it's fruits.remove followed by open bracket, inside which you want to put the element you want to remove, the value. In this case, if you want to remove cherry, that's what you put it there, and then close bracket. So if we print fruits now, let's see. Remember, we had 4 elements before. Now let's see. Now we got 3 elements. That's apple, blueberry, and cherry. Basic slicing. Python slicing might feel magical if you're new to it, but this technique allows you to extract portions of a list effortlessly. Whether you're selecting just a few items, you're reversing a list, or if you want to skip elements, slicing gives you powerful control over your data. Right? In fact, I already have it here for you, so no need to paste. So right here, you have the syntax of how do you do slicing. So I'm highlighting it, and hopefully you can see that. And what it is the name of the list followed by open and close square brackets, and in between those square brackets you want to specify this index where you want to start slicing, and the index where you want to stop slicing, and the step. And one important thing to remember is anytime you specify the index where you want to stop slicing, the element at that index is not included in your result. You will see that in a second. So let me clear some of this stuff up, and let's see. Here I have an array ready for you, fruits array. It's got 1, 2, 3, 4, 5, 6, 7. So it's got 7 elements on it, and let's go slicing it. Okay. So what if we want to extract the first 3 elements from this list? How do we extract the first 3 elements? What should be the start index? What should be the stop index? And remember, if you leave out the start index, it's going to default to 0. So you don't have to specify everything, or the step. You don't have to specify everything every time. So what if you want to get apple, banana, and cherry from this list? How do we do that? Look at what should be the start and what should be the stop. So I'm going to do that just like that. When we do that, we said our stop element is element 3, which means we don't want the element at index 3 to be included, but everything else. So which means 0, 1, and 2, apple, banana, and cherry. If we execute that, you can see that's happening. Now, what if you want to extract, let's say, from element 4 to 5, elements 4 and 5, which is 0, 1, 2, 3, 4, 4 and 5, but not element 6. Okay, so you want 4 and 5, but not element 6. How do we do that? What should be the start? The element at the start should be 4, 0, 1, 2, 3, 4, and then the stop should be 6. Let's see that. If we execute this, you can see we got the element at 4, element at 5, but not element at 6, because our stop index here is 6. Okay, so next thing I want to talk about is slicing using negative indices. Okay, and it's slightly different because when we do negative slicing, we go from the end of the list. Okay, when we go from the end of the list, we assign a number -1 to the last element in your list. In this case, the grape would be -1, fig would be -2, and elderberry would be -3, and so on. So now what if you want to use a negative index syntax, and the syntax is the same. It's a list start and stop, and whatever you specify at stop would not be included. So what if you want to extract the last 3 elements of the list? Okay, you want to extract the last 3 elements of your list, which means you want to start at -1, -2, -3. You want your start at -3. And if you don't specify the stop, it goes till the end of the list. So let's do that, okay? Right, just like that. Now let's run that and let's look at the last one. You can see it started at -3, which is what we specified as our start. And it went to the end of the list, -3, -2, -1, and so on. Now, what if you want to extract from the third last to the second last, right? So the third last, which would be -3 from the last, third from the last is this, and you want to extract the second last, but not the first last. Okay, you don't want to extract grape. So how do you do that? To do that, all you have to do is specify your start to -3 and your stop to -1. So that way, because remember, whenever you specify the index in the stop in the syntax, that element will not be included. Every element before that will be included. So in this case, we want it to be -1 because we don't want to include that, but we want to include the third last and the second last. So if we do this, you can see we got elderberry and fig, but not grape. Okay. Sets. They're like lists, but with a crucial twist. No duplicates allowed. Alright? So they're very similar to lists, but you cannot have duplicate elements. So they're perfect when you need unique values and want quick operations like union, intersection, and difference. So let's jump in and see how they work. Okay? And that's how you create a set. In a set, you have a collection of elements, but like I said, there's no duplicates. The difference between a set, which is a collection, versus a list is, in the list you use square brackets. In a set, you use curly braces, like here. So if we do print this set, using print command, what do you expect it'll have? Right? Do you expect it to print 1, 2, 3, 4, 4, 5, or 1, 2, 3, 4, 5? Remember, what is the unique characteristic of a set? There you go. You see, as soon as you can assign duplicates to a set, but when it gets stored in the memory of Python, in the internal program memory, it gets no duplicates are allowed, and it will only store a single, each duplicate, it will only store one of them. So it won't store multiple instances of the duplicate. So 4 in this case has multiple instances. So as you saw, 4 doesn't get, doesn't get repeated here like I wrote. So the next thing is, how do you add values to this set, right? If you want to add another value, like you can do so using the add method. Okay, let me do this. And if we add that, and now if we print the unique numbers, now you will see that the element 6 gets added to the end of the list. Right there. Now if we do it again, let me give you a challenge. Let's say if I added it again, right? Notice this. It pretty much did not repeat it. It did not add it twice. It only added, even though we added, we called the add method 2 times. As you notice, the 6 did not get added 2 times. It only got added once. So that's the unique nature of sets. Next up, list comprehensions. Python developers love list comprehensions. Why? They allow you to create lists in a single relatable line of code. It's a really simple way to create a new list. Whether you're filtering or transforming data, comprehensions make your code concise and expressive. So let's go jump into the code and see how we can do comprehensions. Let's say we have a scenario where we have a list of numbers, we want to double them, like multiply them twice or something like that. So the way we do it is using list comprehension syntax is just like this. Okay, so squares. So let's say if we have a range of 10, you may be wondering what is range of 10, right? Range of 10 means that we will have elements in here up to 10, which means 0 to 9. So range of 10, let me print out what range of 10 it gives you in this cell here, so that you understand what range of 10 will have. Oh, that didn't print it quite. But range of 10 will have numbers ranging from, like it says, range from 0 to 10. So which means 0, 1, 2, 3, 4 until the number we specified there, right? So but not the number. So 0 till 9. So that's what it will have. So when we do range of 10 like this, and we're saying for x in range of 10. So x, we are going to iterate over all the numbers. So we're going to go over each number, and x get assigned each one of the numbers in that range. So x gets assigned 0 first, then 1, then 2, and so on. And for each one of those times, and every time it is assigned, we are performing an operation on that x, which is we are doubling it, like we're doing a square of it. So x square is what we're doing. Essentially, we're taking x and whatever the value, we're doubling it, and we are storing it in a new list. That's what list comprehension means. And that new list is the squares list here. So if we print out now, if we do print of squares, what do you expect us to see? Take a moment and think what this new list squares will have. Watch that. So 0, of course, when you square it, it's 0. X first becomes 0, and then x later becomes 1. If you square 1, it's 1. And the next x next becomes 2. So when you square 2, you get 4. And so on until, like when you do x, when x becomes 8 and you square it, it becomes 64. When x becomes 9, when you square it, it becomes 81. So that's list comprehension. So list comprehension essentially gives us the power of doing some, create new lists using an existing list in a simple single line of code. So that's why Python developers love this, and this is really cool. I wish more languages have something like this. So yeah, that is list comprehension. Next up, loops. Loops in Python are straightforward, but there are few Pythonic tricks to make them more elegant. We're going to cover both for loops and while loops, plus some common patterns you will encounter while iterating through data. Okay, let's jump to the other screen and see how to create a for loop. So for fruit in fruits, so for and in are the things you need to remember, followed by the colon symbol, the 2 dots thing, and in there for fruit in fruits, fruit gets assigned for each. So we go over in this loop, we go over each one of the elements inside fruits list. And every time we're going over it, each time we're going over one element, it's called one iteration. And for each iteration, the variable fruit, it could be anything, it could be x for all we care. That fruit here, this could even be x, just like that, right? So the x gets assigned the element we are iterating over. So if I remember the fruits, if I can see the fruits here, first x becomes apple, the next becomes banana, then it becomes cherry, date, and so on. So let's print it. Let's execute this and see. Watch. So for each time, x got assigned the value and we printed it out. So x was apple first, and then banana, then cherry, and so on. Now, another popular loop, in Python is while loop. Okay. So let's go ahead and switch and see how we do while loops in Python. The logic, the way while loop works is we basically have a condition which says that while this condition is satisfied, that means while this condition is true, continue to iterate. And as soon as the condition becomes false, you would exit that loop. So in this example we have here, we said we initially had a variable called count, and we set the count to 0, and then while count is less than 5, you keep printing, you said print count. But let's say, and then we go ahead and increment the count. So what does it do? What does it mean? So if count is initially 0, we print the count, it will print 0. And then we incremented the count to 1, and then we iterate again. So we enter the loop again. And then it checks and the count's value now is 1 less than 5. And it is true, it will print 1. And then it will go to the next line, which is where we increment the count. So it will become 2. So then we enter the loop again, and it will check is 2 less than 5. It's true, and then it will print the count 2. Now, at some point, the count will become, 6, or 5 actually. Let's say 5. When it's 5, we check the condition. We check the condition is 5 less than 5. Is 5? That's false. So as soon as the condition becomes false, we exit the loop. So it's going to go to the line next to it to show you the point, to show the value here of print. I'm going to print the value of count outside as well, so you'll see. Let's execute this. You can see right here it printed 0 to 4 and 5. I know this is a bit confusing, so I'm going to print a line, print outside the, just like that. So we will see that it is outside, and you can see. So while in the loop, we printed from 0 to 4 because 4 is less than 5. But as soon as the count has incremented enough to become 5, we exited the loop, and our outside the loop became 5. Now, you may be wondering, how do we do the C style loops we have, like for I is equal to 0, I is less than 5, and so on. So we don't have traditional C style loops like that. So inside Python, for loops are designed to iterate directly over sequences like lists, tuples, or ranges. So to achieve a similar iteration, like for I is equal to 0, I less than 10, I plus plus, that kind of thing, to achieve similar iteration as a C style loop, we often use the range function. So the way we do it is, if you want to iterate over from 0 to 10 or 0 to 20 or so on, the way you do it is for I in range of, let's say 5 in this case, or let's say 6, okay? And then we do that, and then we do, don't forget the semicolon, right? After the while, after the for, we always need, not the semicolon, sorry, column. This 2 dot symbol, column. Make sure you're putting the column after your loop statement, like for or while and so on. And then you want to print I. Okay, well, let's see. See, so this is similar to how we write, how we write in C#, or C, or any of those C style languages. For I is equal to 0, I less than 10, I plus plus. Remember that syntax? So this is similar to that. So typically write it like this, right? And then this is how you write it in C#. So we don't have something like that, and this is how you accomplish similar functionality in Python. Conditionals. Every program needs decision making and conditionals to just that. In Python, we have if, elif, and else. We'll look at how to handle branching logic cleanly and efficiently in our AI workflows. So let me switch over to my computer monitor, and let me paste a if-else condition here, and let's examine this. So here I have a variable temperature set to a value of 75, and I have a if-else condition written here where I said if the temperature is greater than 80, so anything above 80, like 81, 82, and so on, I want it to print it's hot. If the temperature is greater than 60, but up to greater than 60, but up to 80, so 61, 62, and so on, up to 80, I want it to print warm. But anything else, so 59, 54, 23, 10, whatever. I want it to print, it's cold. So let's see. Right now, we start off with a temperature of 75. So think for a moment, what do you think this will print? Let's try. Shift enter. It says it's warm. Now I'm going to change this to, let's say, 81. Take a guess what it will print. Let's try. It's hot, because anything above 80, this condition right here gets triggered and then it prints it's hot. Let's say I want to print something like 60. Okay. Now tell me, what is it going to be? What do you think it'll look at the conditions and see and tell me what is it going to print? If you guessed it's cold, you are correct. So right there. So why is that? Because anything else, if it's not greater than 60, we don't fall to either of these conditions. Okay. So the else condition gets triggered if none of these conditions get satisfied, which is specified in if or elif. Then the else condition gets triggered and else it prints whatever logic is there within the else condition. In this case, it's print it's cold, and we are not limited to a single elif. We can also print. We can also add multiple elifs. So if I were to say that we had this range from 60 to 80, we wanted to print warm, right? Let's say if I want to say if it's greater than 70, I wanted to say it's extra warm. Okay, so if it's greater than 60, I wanted to say warm. If it's greater than 70, I wanted to say extra warm. So let's see. Now, guess what it's going to print when it is 63? Let's try. Take a guess. It will print it's warm. But now notice, if it is 73, on the other hand, or anything greater than 70. So to illustrate the point, I'm going to put 71. So now take a guess, what is it going to print? It's extra warm. So because we added this new condition here, elif, which is if temperature is greater than 70, print extra warm, that condition got triggered and it printed this extra warm. So that's how you do conditionals in Python. Dictionaries. Dictionaries are Python's version of hash maps, where we store key value pairs. They're another workhorse of Python. They let you store key value pairs, which is super handy for managing structured data like API responses and so on. So let's explore them for the full potential, what they are in our switching to our code editor or Jupyter notebook, sorry. This is how you create a dictionary. So you create a dictionary by assigning your dictionary variable, in this case the person, with the value. The dictionary has to stay within curly braces, and then inside the curly braces you have key value pairs, the key and the value separated by a colon, and multiple key value pairs get separated by a comma. So in this case we have a key of name and the value of Samuel, and the next key we have is age, and since age is a string, we surrounded it with double quotes, and the value we assigned for the key of age is a number, so that's why we didn't have any double quotes around it, and we put a number of 30. So there you go. That's how you declare a dictionary. Next, let's see how do we access the values for the keys. So we do that using this syntax. Okay, so it's the name of the dictionary. It's the name of the dictionary. In this case, person is the name of the dictionary, and then followed by open and close square brackets. And inside the square brackets, you want to put the key. Typically, the key is always, not always, but it's mostly a string. So which is why you would put it in double quotes. So in this case, one of the key we are probing here, the value we are trying to get here is the value for the key name. So which is why we did person and open and close square brackets, and inside that we have name. Right, so let's see what it prints. can see now it read the dictionary, and if you look at the dictionary here, we assigned the value of Samuel for the key name. So that's what got printed. Next, we can do similar thing for age if we do the same thing. So I'm going to copy paste that, and age, and if you print that, you can see we now got the value for the key age from the dictionary. Now let's say if you want to add extra values, extra keys, or extra key value pairs, I would rather say extra key value pairs to this existing dictionary. The way you do that is like this, using this syntax. Okay, so we want to add a new key of city, the value of Fort Mill. All right, so the way you do it is using this syntax. You can see here person with followed by square brackets, and inside which you want to put your key, and on the other side, on the right hand side of an equal to sign, you put the value. So if we print our dictionary, if we want to see if this new key got assigned, so we can print it out, of course, like this, using our square bracket notation, and see, right there you go. So we can, I believe we can print the entire dictionary by doing this, and you can see the entire dictionary by just surrounding it, the dictionary's name, dictionary's variable name, person in this case, with open and closed brackets. Okay. Functions. Reusable code is essential, and that's where functions come in. We'll look at how to define functions, how to pass arguments, how to return results, helping you write code which doesn't repeat itself. You know, there is this software code principle called DRY, which stands for don't repeat yourself. We want to make sure that our code is compliant with that, so it's easy to maintain. Okay, all right, let's switch over to my computer screen and let's look at how we define a function. So we define a function using the def keyword, def, just like that. All right, so here we define a function called greet, which takes a parameter name, and then it's going to print out, or it's going to return something which basically says hello with that name. And what you're seeing here with this f and this thing you see here, f followed by double quotes and the string, is called an f string. F strings are an interesting and very useful functionality of Python, right? So it allows you to combine regular literal strings like hello in this case with variables. So it allows you to mix variables with any kind of text. So and it just, as long as you surround the variable, in this case name, with curly braces. So let's try to use this function, pass something to it, and see what it does. Okay, so you can see right here we call the function greet with the name Sunil, and the result we're going to capture in the variable message. Okay, so message will hold whatever the method greet returns now. What do you think this method greet returns now? Take a moment to think. Okay, watch what it will return. So we want to print what the message has. Let's see. See, it said hello Sunil. Now Sunil is the value we pass to the parameter name. So the variable or the parameter name gets assigned the value Sunil. Let's say if we say something like Lucy, right? And if we do that, we printed hello Lucy this time. Okay, so that's briefly how functions are defined and how they take parameters and how they return values in Python. Class and objects. Object-oriented programming isn't always necessary in Python, but it's still important to know, especially when when working on large projects. So I'm going to basically cover how do you define classes, how do you create objects, how do you use inheritance to structure your code efficiently. Okay, let's switch over to my computer monitor and to my Jupyter notebook, and we'll see. So here we define a class dog, and we have also defined a constructor for the class dog using the underscore init followed by underscore init. And the first parameter for the constructor has to be self, which is a reference to the class itself, followed by any parameters you want to add to that I guess parameters you want to add to your constructor, and those parameters, when you use the self dot name, they will become properties or fields for that class. So here we had a parameter name, and we want to assign that to the property of the class dog by doing self.name is equal to name. So if you are confused about the self.name, we can call it anything else. We can call it I don't know, let's call it nickname, right? So now we have defined a variable, a property nickname of class dog. So we can use that nickname using if we in other methods, right, in the class. Like for example, I'm going to define a method now. We're going to call it bark, and we need to make sure that it has a parameter of self. And in here we can now use any properties of the class. So we have one property nickname, so we're going to use that. So we're going to use the f string again, and we will do so anytime you want to refer any of the variables of the class, you would want to use prefix it with self and followed by a dot, and then whatever property of the class you want to use. So here we have one property nickname, so we want to use nickname says oof. Okay, so that's how you define a class in Python. So use the syntax which is showed here. It's class followed by the name of the class object, and then your constructor always starts with has a fixed name. It's underscore init followed by underscore, and the first parameter for your constructor has to be like it's shown self, and then any parameters you want to pass. Any of the properties of the class needs to be prefixed with self, and any methods you want to add to your class, you want to pass self as one of the parameters. Like we added this method bark for the class dog, and then we pass the parameter self. So now the obvious next question is, how do we use this class? Like we defined a class, how do we use this class? How do we define an object of this class? Okay, so let's see that in a second. So the way you do that is, I'm gonna copy paste that just like that. So here we define an instance or an object of class dog, and we passed a parameter buddy, which gets initially passed to the constructor name here, and then that gets assigned to the properties nickname. So nickname will become buddy now. So if we call the method bark on this object, the way we do that is using the dot notation, just like C# or any other language. We can do that just like that, and then if you execute that, that's crazy. All right, that's a syntax error, so I just used the wrong syntax. So if I execute that, watch, buddy says woof. Why? Because the nickname, then we pass the value buddy to the constructor when we pass it like this, and name, and in the constructor the variable name gets assigned buddy. Self is ignored. As you know, self is just a reference to the class itself, like I said, so we ignore that. So we start here after self. The first parameter gets assigned, the first value is here, and here we defined a property called nickname on this class dog, and that gets assigned what's got assigned to name, which is buddy. So nickname becomes buddy. So when we call the method bark on the object my dog, this f string gets returned, which says self.nickname, which is buddy says woof. And that's why you see buddy says woof. So that's how we define classes, that's how we define constructor, that's how we add methods to the class, and that's how and I just demonstrated how do we create an object of the class and how do we call methods of a class. All right, so next up is inheritance. if you want to get good at object-oriented programming, the least thing you need to know is inheritance. So basically, it allows you to implement object-oriented principles by creating classes that inherit from other classes. So let's say now I'm going to define another class, which is a base class. Usually when you inherit from one class to another class, the class from which you're inheriting is called a base class, is often referred to as base class. So I'm going to define a base class called animal. Watch that. So here I define a class animal, and animal, as you saw, it has a constructor just like I said for using the init thing, and we have one parameter name similar to dog we defined earlier, and it has one method speak, and inside the speak, if you notice, there is a peculiar keyword in here called pass. And you may be wondering, what is pass? So pass is a special word, a keyword in Python, and anytime the Python's interpreter sees the word pass, it does nothing. It basically doesn't throw an error, it does execute nothing, it just moves on. So that's what pass is. So the reason why did we use pass here, it'll be clear to you in a minute. So why did we have this method which does nothing? You'll be like, why? So you see that, okay? So we are going to be implementing that method speak in the child in a child class which inherits from animal. So let's say we have an animal, a dog class, right? So for example, here I have a dog class, and the dog class, similar to animal, has a method speak. But you notice how I define, how I specified that the dog class actually inherits from animal. I did that by passing the name of the class it is inheriting from in the definition of the class. So here, I'm going to highlight it, how we established that inheritance right here. So dog followed by open and close brackets, inside which you put the class you are inheriting from. So dog is inheriting from animal because that's what we had in between the braces here. So, and after that, business as usual, you just define your methods for the subclass, or you can also define methods from your parent class being animal, from the class from which you're inheriting. Once you define that, this method which is defined in the child class, which is speak, which I highlighted here, takes precedence. So if we were to create an instance of my dog, and let's just like that, and we do buddy, or let's say call it Mickey, just to show a difference. And then if we do print my dog dot speak, that's how we call the method. And what do you expect it to print? It will print Mickey says woof. Why? Because again, the name, dog takes the parameter of Mickey, which is I know the dog did not have a constructor. So how did this parameter where did this parameter Mickey get passed? Well, because dog inherits from the class animal, and animal has a constructor which takes a single parameter name, like I explained earlier. This name gets assigned Mickey, and then when you call this method on the child class being dog, and when you refer self.name through inheritance, this name which is defined in the parent class animal gets passed down to the dog class, and dog class will now this variable self.name now will have Mickey, and then it will print Mickey says woof. Similarly, let's say if I define another class, right? I can define multiple classes which inherit from the animal class. Let's say I define cat, okay? It also, and by putting animal in between the parentheses here, I'm establishing inheritance, so between cat and animal. So cat inherits from animal. So the speak method, of course, cat will not say woof. cat will say meow, right? And so if I were to say my cat is an instance or an object of the class cat, and then I say pass, okay, let's call it pass. I know it's not very creative, but that's what I can come up with right now. Mine is called cat.speak. If we do that, let's see, watch that. So now we have my cat, which is an object or instance of the class cat, and when we used this class, cat class, and when we call the speak method on the cat and on an object of cat class, we are invoking this method right here. And this method, the f string says, has a name, says meow, and that's what got printed, pass says meow. So that's inheritance for you in Python. Now, Python has a very rich ecosystem of modules and packages. So I'll show you how to import built-in and external libraries to extend your program's capabilities without reinventing the wheel. Alright, let's switch to my monitor and let's have a look. Alright, so there is this package called math. It has a lot of cool functions for doing different mathematical operations such as square root and things like that, average and all those things. So we're gonna, anytime we want to import a package, external package or built-in package or whatever, so if you want to import it, we do the syntax import. So we do import. In this case, we are importing the math package. We did import math. So similarly, there's another package we're going to import and we're going to demonstrate. That is the operating system package or OS package shortly. So we do that using import OS. So this package helps us perform a lot of operations on the operating system, such as in this case, we're going to use this package to read environment variables. And then once we import the package, we can use the methods which are defined within that package using, by prefixing that method with the package name. In this case, when we wanted to use the square root method, okay, when we want to use the square root method which belongs to the math package, we do math.squareroot, just like I showed it here. Okay, so we're going to do math.squareroot, and then in the square root, for the square root method, we call whatever parameters required for that method. In this case, we need a number to find a square root, so we did that. Okay, and similarly, the operating system package or OS package has methods which perform different operating system operations. So in this case, we wanted to read environment variables. So we use the getEnv method, and we got to pass the environment variable we want to read. So let's try that. And here in this example, I'm trying to read the environment variable processor architecture. So this variable would have reference to the kind of processor you have, if you x86, things like that. So let's run this and see how it behaves. There you go. So the square root of 16 is 4, as you know. So that's stored in the variable result here. And when we printed result, we got that. Similarly, this variable I defined procarc or processor architecture, short for processor architecture, has stored the value of the environment variable processor_architecture. And then when we printed it, it printed AMD64 because I do have an AMD processor here in my system. So that's how you deal with external modules and packages in Python. Now, the next important topic I want to talk about is using environment variables to secure your data. I know I covered this in earlier tutorials, but this is so important that I want to cover it once more. So anytime you have sensitive data, like API keys, you never should hard code it. It's such a big no-no. Never do that. All right. So the next thing is, how do we then secure these these secrets like API keys? Well, that's where environment variables come in. I'll demonstrate how to manage these variables securely using the .env files so your secrets stay safe. Let's switch to my monitor and let's have a look. First thing you want to do is you want to create a file whose name is .env, and there has to be no extensions like .txt or something like that. Just make sure it has no extensions. it has to be, the name has to be .env. So already created one in my case. So if I switch over to my LangChain 101 live folder, you can see I created a file .env, and if you can open that up in Notepad, and in there I have a key, an API key. This is obviously a fake key. I'm not going to put the real key here, but this fake key I had, and here has a value of GH7. So this is the OpenAI API key. That's the key, and the value which I assigned to is on the other side of the is equal to sign. So that's how you want to put your API keys and secrets in here, any configuration in here. Now the next question is, how do you read the values from this .env file? To do that, we use a Python package called I believe it's python-.env, or .env, python-.env package. So we use that package to read keys from .env files. So let's see how we do that. So gonna paste my code here. Okay. As you see, we import the package from load_.env, the method. We import the method load_.env, and we call this method load_.env, like here, and that would read the .env file and load all the keys which are in the .env file into our environment variables. And as we saw earlier how to read the environment variables using the OS package, we're going to proceed this same way. So let's go ahead and try this, and we want to print the variable we read from the .env file like this, and you can see we're able to read that. So it's simple. The package we want to install is python-.env. We want to install that, and then we want to specify that from .env package, we want to import the load_.env method. So we don't want to import the whole package, just that method. Okay. So once we import that method, we want to call that method like right here, load_.env. We simple method calling syntax. This would load all the variables from the .env, and then we want to use the OS package to read the values which are loaded from the .env to the environment variable. So when we call this load_.env again, all the keys which are defined in the .env file gets placed, become environment variables, and then we proceed to read the environment variables using the OS package. Okay, and we do that using this getEnv method, and followed by the open and close parentheses. In between that, you want to keep the API key you want to read. So that's how we secure our API keys and other secrets. And another thing, if you are using Git, just make sure that your git ignore file, the .git ignore file you have in your Git repository includes .env in there. So you never want to push the .env file to any kind of source code repositories, because it has secrets. In production environments, you ideally want to hook in some kind of pipeline. That way, your environment variables and your secrets get read from Key Vault or other kind of secure places instead of .env. But this is good enough for local development and other kind of situations. All right, let's speak about exception handling. Errors happen, but your program doesn't have to crash. Python's try except blocks allow you to gracefully handle errors. This is a crucial skill, especially when working with APIs and any external data sources, because you never know what kind of errors come from those sources. So let's look at them. Let's switch to my monitor and let's have a look of how we do exception handling in Python. Here we go. This is the syntax. So we have a try block, we have an except block, which catches any exceptions which are thrown by the code within the try block. In this case, it's result. So when we're trying to divide something by 0, we have this popular division by 0 error exception or error. So our except block is designed to catch that error. In this case, 0 division error, and it will print out saying cannot divide by 0. And then the finally block, which starts here in the finally, in the, when you see the finally thing, finally keyword, that's where the finally block starts. So anytime an exception happens, the except blocks gets triggered. There could be multiple except blocks. The except block which has the error, which closely matches the error, which closely matches the error that is triggered within your try block, gets triggered, and that catch block executes the code inside that catch block. The except block. In Python and C# we call them catch blocks, but here in Python we call them except blocks. So the except block gets triggered, and whatever code is within your except block gets executed. In this case, it prints out that cannot divide by 0, and then the code execution moves on to the finally block, and it will execute that. But the interesting thing about the finally block is whether you have an exception or not, the finally block will always execute. So watch. Let's run this, and you see we caught an error, cannot divide by 0, because you cannot divide something by 0. And so it executed this line, this print here. Okay, it executed this print here, and then it executed the final block. Let's say if we don't have an error, if our code didn't trigger an error, didn't cause an error. Let's say we're dividing 10 by 1. Well, in that case, it's perfectly fine. 10 divided by 1 is 10, and there is no error there, right? So do you expect the except block to be triggered? No, it will not. What about finally block? Will that be triggered? Yes, it does get triggered. Let's try this. See that? The finally block will always execute. Now you may be wondering, why do we need to do this? What happens if we don't have this, if we didn't surround this this whole operation 10 by 0 with this try except block? What happens in that scenario? Let's try that out. So if I do this, okay, and I removed this, I deleted this entire try except block, take a guess of what happens. Let's say if this line of code is in your program and it didn't have any try except block, what happens? Let's see. See right there? See this error? So it's saying, okay, 0 division error. It threw a 0 division error, but since there is no except block or catch block in C# world, no except block in this case, so the error bubbles up and your program crashes. You want to avoid that situation. You don't want your program to crash. You want to handle any possible errors, any known errors gracefully, and that's where try except block comes into play. So let me put it back, and there you go. In this case, our program didn't crash. It told the user or whatever system that, hey, you just can't do this operation, and then it went on. It went on executing the next line, whatever is in finally, and moves on. If you need to exit gracefully, you would typically use the finally block to, let's say, terminate network connections, terminate database connections, and so on, and release the resources and exit the program gracefully instead of dropping dead and causing memory leaks, network issues, and all that stuff. Finally, the moment you've been waiting for, integrating LangChain. We'll combine everything we learned to set up LangChains and prompts to AI models and get responses. This is where your AI journey truly takes off. Get ready. Let's switch to my monitor and let's have a look. First thing we want to do is we want to import the packages for OpenAI. So we want to import the LangChain OpenAI package, LangChain_OpenAI, and then we also want to import the prompt package, which helps us build the prompts we need to send to the LLM engine so that we can receive a response back. So let's import those two packages. Okay, just like that. So the two packages we imported, just like in the syntaxes I showed earlier. So from the package name, import what feature or what function of that package you want. So from LangChain_OpenAI, we want to import the OpenAI. From LangChain package, we want to import the prompt template so that you can construct prompts which we can send to our LLM engine. Next, and the most important thing, like I said, is you want to get your API key read from your .env file. I hope by now you got an API key. If not, I'm going to show you in other tutorials how to get an API key for your from OpenAI. And then I hope you got an API key from OpenAI and you added it to your .env file. So we want to do is from .env package, we want to import load_.env. I did that. I already added, I removed my dummy API key for OpenAI I had earlier, and I replaced it with a real API key. And one more thing I want you to understand, I want you to just make sure that when you put the real key, you surround it by single quote within your .env file. The value, I mean to say, like you want to do OpenAI_API_key is equal to open and close single quotes, and in between those single quotes you want to put your API key. That's what I did, and then I'm gonna read it into my environment variables by doing load_.env method, by calling that just like that. That would load that API key and make it available as an environment variable. As long as the OpenAI API key has the name OpenAI_API_key, this package OpenAI will look for it in the environment variables and read it. So we don't need the import OS and all that stuff in this case. So watch. So the next thing we want to do is we want to initialize the OpenAI model, and we do that by calling by instantiating an object of type OpenAI. And in this case, we created an object by name LLM, and then that would hold a reference to the OpenAI class. And to the OpenAI constructor, I passed a parameter called temperature, which tells it how creative it needs to be, and 1 being the most creative and 0 being the least creative. I passed at 0.9, so the responses from the LLM will be not boring, it'll be more interesting. So that's why I did that. Next thing I want to do is I want to construct my prompt template. Prompt template is basically like when you use ChatGPT and you type your text, that's essentially what it is. That's prompt. You're prompting your LLM engine, and to do that programmatically, you want to use a prompt template. And when we discuss prompt templates, when we go down to the details, if this prompt template is confusing for you, don't worry, just think of it as typing the text. And in this case, I am passing in the text saying, I'm constructing a prompt by saying, whatever I give in the variable text here, like this text variable here, convert that from English to French. I'm going to pass an English text in here, convert that to French. Now, I don't want this prompt template to be a fixed literal. I don't want to specify what I want the English text to be. I want it to be passed in at a later time, which is the reason why I use an input variable text here. And and I refer that in my prompt, like using curly braces, right? So any input variables which varies in the future, you would want to surround it with curly braces and then specify it in the input variables parameter to the prompt template constructor. So now I have an instance of prompt template, an object of prompt template in this template variable. Next thing is the next step is we want to specify what is the value we want to pass to that input variable. We do that using this format method on the template object instance. So template.format, and here we want to pass the input variable name and the value we want to pass. In this case, I said, hello, how are you? That's what I want to say. That's my prompt. Let's print and see. And if you see, this is the prompt, this is the text. This is the same thing as if you're typing in ChatGPT a text, right? You type something. If you want the ChatGPT to translate something, say translate the following text from English to French, and then you put whatever you want the ChatGPT to translate, right? And that is what we just constructed using a prompt template. So if you want to change, let's say you want to ask them how far is Paris from here, right? If that's what you want to ask, we can do that too. And If we were to, like pass this as this value as a parameter, as a like something we get from an API or from a variable, using input variables allows us to do that instead of hard coding a text value there. So now the next thing, the moment you are all have been waiting for, now is the point where how do we now send this prompt to the LLM engine and get a response. So let's do that, okay? Okay, just like that. We use the invoke method on the LLM object, and to the invoke method we pass our final prompt, our prompt text. We want to, which normally you would be typing in ChatGPT chat window. That's what you're passing here into your invoke method. So let's see what response we get. Okay, see, that says, like, I just can't read it. It's bonjour, quelle distance. I'm sorry. If you guys know French, you know how to read this. But you saw it is it translated, hello, how far is Paris from here? Got translated to French, and you see it right there. So this is how, this is a culmination of all the Python syntaxes, Python concepts and fundamentals you learned can be put to use LangChain to talk to any LLM engine out there. I mean, of course, in this course we'll be using OpenAI exclusively, but you can literally apply the same principles for any AI engine out there, be Llama or even the DeepSeek or anything. As long as they have integrations with LangChain, you can use them like this. I hope you're excited for that. In the future tutorials, I'm going to show how to construct prompt templates and all these details. I mean, if it's a little bit confusing, if it's a little bit hazy for you right now because you just learned Python fundamentals, this may be a little confusing for you. It may be you may be a little bit lost, and that's fine. That's totally fine. Just go back and revisit revisit the fundamentals. Watch this tutorial again, and that way you get a good grasp of all the Python fundamentals, and you'll be able to follow code like this in upcoming tutorials. Thank you.